I guess we should start now. So I sent this CSV file, which was titled Uber Drives 2016. So that's the file we'll be using for data analysis today, right? So, okay, one thing. So typically, I mean, you have different sources of data, right? So one common one is, sorry, let me shut this. One common one is this, it's Kaggle, I think that's how it's pronounced. So Kaggle data sets. So here on this website, you get tons of data sets of different types for different projects, computer science education, nonlinear programming, I mean, natural language processing, data visualization. I mean, there are tons of data sets here. I think it's free, but you just need to sign in for you to download any data set. So it's just kaggle.com/data sets. Let me see. Let me see if I can put this in the chat. So in case you need to copy the link, then the data set we are using today, I got it from there, which is this, Uber Drives 2026. So most of the data, I think most of the data sets there is just 17 kilobytes. Most of the data there are real data, right? Real data. I think this is the history and everything. So I downloaded it from there, and that's what we use for the analysis today. So I mean, that's one site. There's another one is from, I think, the university. Yeah, okay. I think it popped up just now. University of California, Irvine. That's another. You have tons of data sets, real data sets there for classification, regression, and everything. So if you need data sets to use, that's one place to go to. That's control. So the links are in the chat already. Okay. So, okay. So today, for the data manipulation and analysis, we want to use the Pandas library. This is one of the common libraries. If you can remember from last week, this is one of the libraries I did mention to you. That's very important. It's for data manipulation and analysis. So it's pre-installed already, meaning we already have it installed in Python. I mean, that's in Anaconda. You can still verify that from with this. I think I gave this last week. Install that's. Oh, sorry, that's PIP shift enter. So this will run. So this command is to install a library. If you need to install any library, the exclamation mark pip install, then the name of the library it should install. It's currently run. That's why we have this asterisk here. So when this is done running, it should show all the libraries that are already installed. You can always install yours, as I've just explained. So your Pandas is pre-installed, I guess, because it depends on how fast you, okay, it says requirement already installed. So Pandas already installed, basically. So find the list, just pick lists, and it shows you all the libraries you have. So if we scroll down, let's see. Sorry, okay, yeah, this is it. So it's installed already, and we have, and the version is 1.4.2. So that is that. So we comment it, then close it, all that. So Pandas can do a variety of things, right? So one thing it can do, it can read your data sets. If you have a CSV file, text file, that's Excel workbook. I mean, XSLX, I think that's what it is. Yeah, you can also read those files. So if you want to import, if you want to start using a library, you have to first import it, right? It's like you're importing all the models in it and what it can do. So the command to do that is import. So it follows this format. Okay, let me do it this way. This is the format to import a library. Import the library, that imports the library as an alias, right? So an example is import Pandas as. Typically it's PD. So what this means is the library is Pandas. Then we are, instead of in this code, instead of always typing out Pandas, we simply type PD. It recognizes PD as the same thing to access that library. So if you do that, if you do this, you've imported that library, and you can then make use of the functions of every of the functions available in Pandas by just typing PD. This is pretty standard. So typically, so if I type the hash sign or key, it means anything after that is not seen by the computer. So you just, some side notes, is an alias for Pandas Library. So that is that. So if you run this, it means the library has been imported. So you can start using that for any of your analysis. So now what we want to do is the Excel file. If you look at this is the Excel file, right? So this Excel file, so I've opened it. Different categories. So this Excel file is data from a particular driver, from an Uber driver. He's documented his trips, basically. So he's shown maybe for instance, on the 1st of January 2016 at the specific time, 9/11, right, at the specific time, and to this time, he went on a trip, and the trip is purely for the purpose of business. He started from here, he stopped here. So the number of miles are recorded and the purpose, right? So he's done that and he's documented that. So you can always have data of different formats and types. So basically he's done that for different times. That's the trips he's taking, the start time to the end time, the purpose and everything. He's done that for a lot of data up to 1,000. I mean, there's a large number actually, 1,156. So that's the data we have. Excel. So now we are going to do some work on this data with Python. So if we come to this place, the first thing is to read this data. Read it. That's to say through Python, you can access it. So in doing that, we assign, let me write the code first before I explain. PD, score. So what we've done is this, right? Okay, I've not run the code yet, but this is what we've done. So the library is Pandas, which we are going to be using analyze, that's PD to stand for that, right? Now, in using this Pandas library, if we want to read a file, for instance, we want to look at the contents of this CSV file. Remember, this CSV is in your working directory. If you want to look at the contents of those files through Jupyter Notebook or with Python, right? So what we do is pd.read_CSV. That's a CSV file we have in there. So pd.read_CSV, then the name of the CSV file, which is Uber drives, just the way it is basically. That's the name. So DF, this DF could mean anything basically. This DF is like we are trying to, it's a copy of what's there, right? Like a representation of what that is. And this is, but it falls under the main class, a group of data called data frame. That's the name basically. But you can name this anything. It doesn't necessarily mean because it corresponds to that. But if I run, okay, so if I run this cell, it means we've read that data. Then to see what's inside this DF, you could type DF straight away or just use DF print. Let's run that. Okay, let me use a different method. Shift. I want to do this one. Okay, yeah, this is better. So so this command reads the data, right? If you look at this data, it reads the data. If you look at this data, it corresponds exactly to what we have here. If you look at this business, 4th PS and everything, that's 5.1, all that. If you look through Python, we can see exactly the same thing here, right? So once again, we call the library dot, that's the method. Then the method is read_CSV bracket the name of the file, and it reads it, which is this. You can call this anything basically. The name just tries to show that this data has been read, and the type of this data is a data frame. So it prints out the number of rows and there's number of columns. You can clarify the type. This is a data frame. So if you type this, I think from last class I explained what you can do with type dft pandas, that's called data frame. So that's how to read data that's how to read data basically. And that's on the assumption that this file is in the working directory, right? Peradventure you don't have this file in the working directory. Another way, what you can do is this. Okay, let me show you. Let me do this. So let's assume the file is in your desktop. Let's assume the file is in your desktop, right? Sorry. Yeah, okay. Let's assume the file is in your desktop. You can also read it from your desktop this way, just in case, right? Just read. Actually, see. You could just copy the working directory if you know what it is. think it's slash this slash desktop slash. Okay, sorry, let me do this. I think it's sorry, I don't make any mistake. It goes straight to let's see, desktop. And this is through the desktop, we have the file here, right? It's just here. Okay. Oh, I guess I'm better off typing it. I can't find the directory. Desktop. No file found on desktop. So, okay. And let me move it to, sorry, so I think it's a little bit. So if we have it here, let me see. Yeah, exactly. I think that's what I'm trying to do, the file part, right? I don't know. Where is it? That's what I'm trying to see. Okay, clicking on the file. Okay, thank you. Yeah. Oh, yeah, sure. Thanks. Here. Okay. So, yeah. So, this. Should work. Okay. Yeah, I think that works. Yeah. So let's see. Not defined. Okay, yeah, that works. Yeah. Okay, so you just copy the file part and put that in here. So either if this is in your working directory, you run it this way, that's this, or you just copy the file part. Take this. Just copy the file part in, that's between the quotation marks, then you run that here. So that's how you read your files, basically. So the next, so then, I mean, when you read your files, you see it gives you the number of rows versus number of columns, but you can still verify that by length. That's this length. That's the number of rows, basically. It gives that out. If you look at your data, this is DF, right? We have that's the number of columns. This is the index. The first one is the index. Then we have start dates, end dates, categories, then the starting location, stop, miles, and purpose. If you every time you run this out, it prints out everything. So you can do df.head bracket. If you want to print out the first five rows of the data set. If you do dot tail, it prints out the last 5 rows, which is this. Last 5 rows, basically. You want to see the type of for each of the columns, basically, or the series, the type you do df.d times. I'll just take this one. Okay. So it shows the different types. So the data sets we have the columns, most of them they are objects, they have mixed types. We only have maths, which are just numbers and of type float 64, basically. Then so for this dot head, it's automatically, if you type dot head, it prints out that first 5 rows, right? You can make adjustments to that if you want the first 10. So that does that for 10. Does that for 10 as well too. Okay, that's that. Any questions? Yeah, let me see some.
Oh, so I have a question. A question.
Sure. You can go ahead. Is it what you?
Sorry, it's just yeah. It's what I typed. How do we read the file? My network was not great.
How to read the file is this, right? So first of all, you import pandas as PD. PD is an alias for that. PD.read_cv. Then since the file is already in the working directory, you just write out the name .csv. That works. But if you have it in another location, then you copy the file part and put that in between. You put that in brackets between the quotations here. So that's how you read the file. So we have this.
All right, thank you.
Sure. So for different columns, we can also count the number of variables. One thing you can do analysis, you can count number of variables in the columns. Because typically, if you have it, like data set from the industrial, so you typically have very large data sets, right? So one way to assess the columns is by df, that's the data itself, square brackets. Start. Let's use the column start. So can somebody please mute himself? Start this. Let's see. So I think it's value underscore counts. Somebody's not. Okay. No, this is wrong. Okay, so if okay, let me I'm jumping the gun here. Let's go back. So if you want to assess any of these, so if you look at the data set, we have like rows and columns, right? But for data frames, ideally the real names are series and data frames. So different series make up a data frame. So for instance, this start data is a series, this end data is a series, category is a series or so, and a group of these series make up the data frame itself. If you want to assess a particular series, or if it's say column, ideally if you understand it that way, this is one. For instance, this is df is the full data, which is this. Then start. So if you notice, I'm adding an asterisk. That asterisk is part of the data based on what we have here. It's not a command, it's not a command, right? Or part of the code itself. It's based on the data. So data frame, square brackets, you can assess. You can assess any of this by this command. So if you do this shift enter, you see you get number of columns from 0 to this, and that is the start here. Similarly, you can do if you change what is here to, let's say, end underscore date, and you run this. And you run this, right? So you see end date, it gives this column. What is here? That's what comes out here. Similarly, if you, same thing, if you change this to right, if you change this to purpose, then that's what pops out. If you want to count, so if you want to count the unique, you want to count the unique variables in each series or columns, you can use .value_count. So what that does is, for instance, the starting location, if you remember in the Uber journey, is every starting location, the number of times they started from a particular location carried 201 times of an unknown location and all that. If you look at your data, the same thing from here, right? So what that does is, it comes to this column, this carry, it starts here and counts the number of carries you have in this column. If you keep scrolling down, it counts the number. You can do the same thing for each of the rows or each of the columns you want. So that's what this dot value underscore count, then brackets does. Then if you, I think, yeah, that should work. But let's see. So I see, yeah, this makes it a bit, I mean, this, let's see. So this, yeah, so okay, this just lists it all out. This gives the top 5 or so, or 10, depending on what you want to do. Mix that out. So another way you can look at your data is .info. It gives you the information about the data. So the full data set, it belongs, is a data frame. The range from 0 to this number of rows, total number of columns, 7 objects. They are of mixed type, none, there are no zeros there in it. Then float 64 and all that. Memory just gives the summary of the data. Basically, I think another one should be the describe. Describe gives like the summary statistics, I think. Yeah. Yes, okay. So describe gives the summary statistics of your data. And if you notice, it's only bringing out the results for miles, and that's because miles is floats. That's the only numerical data you have. The rest are objects. So it counts the number, the mean, the standard deviation. I think this percentile, that's 25, 50, and everything. So, and the maximum value. So that's what that does. So then if you want to do, let's do some data manipulation. So, okay. So if you want to select a particular row or column, I try to select, or select or probably access rows. There are 2 ways to do that. This position-based indexing. This is position-based. Okay. Sorry, let me change this. So if you look at your, so there are many ways to access rows and columns in your data set, right? So let's do this. For instance, if we want to look through the data set itself, I want to select, let's say, the first 5 rows and the first 3 columns. How do we do that? So we use the data set itself, which we've already made an instance of. There's df.iloc. So we can use iloc or we can use loc. I've explained the differences basically. So for iloc, you are going to be using, we are using the position of the data itself, right? So let's say we want the first 5 rows, we use square brackets, 0 and 5. So with this, we selected the first 5 rows. That's 1, 2, 3. Index starts from 0, 5 rows, then 3, then okay, these 4 columns, and 4 columns basically. So that way we can just access specific rows and columns we want. yeah, we want basically. If you want, let's say, let's say we want just the first, let's do this. So then another example, if the first 5 rows, and let's say you want the first column, which is start date, and the 4th column, it shows this, right? Stop. So you can use this ilog to do that. So the first, you select for the rows first, then the columns. So from 0 to 5, that, I mean, just you can also run the whole of the rows. That's, you can select the whole rows that by doing this. So if you run this, you see that it produces all of the rows. Starts from this to 1,155. Then the first row and the first column and the 4th column as well. If you want it to be the 1st to the 4th, you do this. Okay. No, sorry, I threw that around. This. Oh, I'm editing the wrong thing. Yes. So this prints out that it doesn't select any of the rows. It leaves them as they are, only takes from the 1st to the 4th column, right? So basically, if so under this ilog, there are 2 areas here separated by a comma. The first part is for the row, the second part is for the column. If you want all of the rows, you just put it in the column, then this you specify basically from 0 to that. If you simply do this without specifying anyone, it's as good as just printing the whole of the data like this. It's as good as just printing the whole of the data itself, right? So if you look at the data, you can see NaN, that's not a number. It means there are blanks in this part. That's what it means by NaN. So I hope I'm explaining it clearly for you to understand, basically. Right. So if you also notice, anytime I run this, like if I run this, let me do this here. Why this displays all of the data, but if you notice, you see that from the data is truncated, right? From you can see the first 5 rows, like in the next 5. First 5 rows and the next 5. So what you can do, if you want to see all of this in a cell, you can write, let me write the code.
Sorry, please, I can't see your screen anymore.
Oh, really?
Yeah.
Oh.
That should be your network.
Yeah,
you log in and log out again.
Can everyone else see my screen?
Yes, we can.
Yes, I see.
All right. So if you want to display all of the data, let me see. So if you notice, anytime we run this, right, we just see the first 5, that's the first 5 rows, and the first 5 rows and the last 5 columns. But if you want it to always display all of that, I'm trying to remember the command. Okay, pd dot options. Yeah, options. Display dot max. So if I do this now, let's see. So So now when I do this, it runs, it shows all of the data without skipping anyone. That's if you need to really see all of them, right? It shows all of that without skipping anyone. So this command is like that's pandas.set option. That's for it to then display dots. I mean, sometimes you don't really need to memorize, or I mean, you don't really need to memorize any code, but just know what you want when you need it, right? So if you run this, it just displays all of them so that you can see all you need to see every instance. So if we do this, let's see, ilog. So let's say we can do this. If we, like I explained, with the colon, you get all of the rows, comma, then you can still do all of the columns minus the last one. That's without having the last one. So if you do this, okay, let me scroll down here so you can see. So you can see these are the columns, right? If you do this, I call this df1. So if you notice, anytime we make any adjustments to this, we don't change the data. We're only just making a representation for what representation which we can see. So if you run this, semicolon. Okay, let's try this. Still the same. Okay, sorry, it's my fault. My bad. So we can if you need only, you want to take off the last column, but you want to display all of them, you use -1. If you look at this, we have start and like that. If you look at the output of this, it still gives this. Let me see. I think we should be able to make a representation of this one. Right. Yes, that works. Let's see. Right. Okay. Yeah, it prints that out, but I don't like this format. So print that out. Do that. Right. So that's that. If you use typically if you just use the semicolons without the -1, it prints all out. But if you want to take out the last column, you can use -1. That's another thing you can do. So let's see. You can also do that for the rows too. I mean, put -1 where you need to, it should work. Let's see, shape. Let's see. It should work, right? df1.shape. Yeah, okay. So you see this one column is off basically. So that's what stopped here. Any questions? Okay. So the second one is using the lock. That's this one. You use the names of the columns, right? So if you want to look at the names of the columns, this is this. It's not. So by just running the data, let's assume you don't even have access to this. I mean, you have access to the data, but they're so large, right? And probably so many columns. By typing df.columns, you can get, it produces the index, which you see the names of the columns out there already shown, right? You can still you can convert that to a list if you want by this df.columns. And that changes that to a list. You can give this a name to probably say x equals to more my list. All right, so if you type my list, right, that's that. And just to confirm, if you check that, that should be a list. Okay. So I guess that's that. So let's see how we can filter data, right? So let's say you want to look through specific columns and see the kind of data, or maybe make some conditional filtering. Let's see how that can be done. So first of all, just some release what our data looks like, right? So DFD. So DF this. Let's say we want to look through the column of, let's say the mouse, this square bracket, quotation marks, mouse. If you enter this, okay, sorry, I know where that's star. Yeah. So looking through, if you look through this, so we just assessed the mouse, that's the column, the column mouse, right, which is this, right, by this command, basically. So if we want the data, if we want to now see, let's say for instance, we want to see the number of miles that are greater than 10. It will return whether it will tell you if, for instance, the first one, 5.1 is less than 10, so it will return false. So it's going to do that for all the points. So as you can see, it returns false, true, and for each and every of all the points up to the last one. If you scroll to the end, we get this. So we can also, another thing we can do is that we can create another data frame from this. Data frame. 10. So how do we do that? We go to this. Let's see. Okay, so as I explained, for this one, for using the that's the lock, right? LOC, you can simply use the names specifically. For in the former iLock, we use the positions. So for this df dot lock, no square brackets, df square bracket, yeah. Greater. Okay. So I keep forgetting this stuff. So what I've just done here is this. If you look at, first of all, this is data frame that contains all of the data, right? As if you look at what I've highlighted, then I'm just looking at the mouse column, the column that contains only the mouse, basically. Then for these mouse that are greater, then print out the mouse that are greater than, create a data frame for just the mouse that are greater than 10. Just print that out and store it as df2. So what I've just done is data frame df, the mouse, look at the mouse column, those that are greater than 10, that value 10, then print that out and put that as, and store it in df2. So if you look at this, that's what is here. How do you can verify that? Because if you notice this starts, you see the numbers instead of 0 as we've had here, 0, 1 to the end, they're starting from 4, right? 4. That's from here. So if you also look at this data, you can verify that. Let's see, the miles are greater than, let's see. Yeah, so you see, it picks this one because 63.7 is greater than 10. It skips this, comes to this. So that's what the code has just done. Yeah, that's why you can confirm that by the index. Also, you can filter by, so yeah. Oh, okay, yeah, so with this same code, what I've done with this is just, let's see. Yeah, we've sorted this data by just using miles that are greater than 10. You can also decide to print out only miles by doing this. Let's see, 10. text to select square brackets. If you print out the F2. So this command, I mean, it's basically the same thing as this, right? We picked the mouse that are greater than 10, but what we did is that instead of printing out all the columns, just print out the mouse alone, so it's exactly the same thing, but just by printing out the mouse alone, we added this here. I'll share this notebook, so in case if I'm probably too fast, you can probably do that on your own later. So that's that. Then I mean, you can, let's see mouse, yeah, you can still do this for more. Let's see. I think we should work too. Let's see, purpose. Yeah. So if you need to print out more than one, you just simply put a comma and then put it in that, like assume you're writing like in a string then this way. So that works that way as well too. Yeah. Any questions? So okay, so let's try something else. If you look at the data here, let's look at this data. Let's assume we want to find all the rights. Because remember, we have the start time to the end time. Let's look for all the trips where the driver started from. Let's say Carry, right? Let's look for all the trips that starts from that. The starting location was Carry. I mean, though we could scroll down and look through all of them, right? But let's assume the data set is very large. I probably cannot do that. How do we write the code to find all the data? I mean, all the rights that started from Carry and the mouse and the corresponding mouse. So one way to do that is it's a df3. You can call it anything, basically something that you can actually remember. Let's do this square bracket. So the starting location should be start. I'll explain what I've done under the code first. The location. Then should print out the corresponding mouse. Okay, so you're looking at, you're trying to find out all the rights that started from a particular location, Carry, right? And for each of those rights, print out the miles that were traveled. So what we did is this, right? First of all, we have the data, that's df, we have the data. We locate the particular column, which is the start column, where this trip was started, right? So in that start location, for every trip that the location was equal to Carry, if you see this is at double equals to sign, right? Equals to Carry. I think one of the notebooks I shared, I explained the double equal to Carry. So for that, locate that in the data frame. So it's kind of like a recursive method, right? So data frame df, locate the start column, then trips that started from Gary, which is double equals to this, right? Then inside, then locate that, and for each of those, print that out with the corresponding miles. So that's what this has just done. So it has done that, which is all this, which is where you're seeing. So this is that's the index and the corresponding miles, the trips basically, and the corresponding miles. It's done that to the end. Another example, let's look at this. Find trips. You can also make it conditional, right? Find all the trips that starts from carry and let's do all first. Take a look at this. Okay, Maurice view. So we want to find all the trips. We want to find all the trips that started from carry or Morrisville. And for all of those trips, we print out the miles. Let's see, my right stance. Scroll back to this command here. So what I've just done is this: I've written the command that goes to the data, that looks into the data set. So this is the data set df, right? Then it looks at a particular column, which is the start column. And the start column uses the command is in. This is in. I think I'll explain this later. It's more like it's maybe a bit confusing now. But using this command, it looks at all the trips that started from carry or Morrisville. So for this case, any trip that started from carry or Morrisville, it prints that out. It prints that out based on its location here. So if you look at this is the full data set. So it has scrolled through. This is start column, either carry or Morrisville. That's what it has printed out here. So basically, that's what. Sorry. So that's what this command has done. So if you notice, we've just created it, like I named this separately, right? So we have to it's separate. I mean, you could still do it without my right equal to a variable or even to a variable name, but I just did that. That's where we define this basically. So if we look at this, let's see, so this is separate, I think, yeah. So if we do location, let's look at the first 5 rows like this. First 5 rows and keep the columns like that. So because it's based on the locations, it prints out, you see, all the rows are there and it prints out the columns, right? Which is this. But if I repeat this same thing, I repeat this with ilog. I repeat this with ilog because ilog takes into cognizance the number that you see, it prints out the number instead, 7, 8, 9, the ones that correspond. So, so the aim of doing this just show to you that one is position based, one is location based, depending on what you want to do and how easy it is to do it. I think that's the name right here. Any questions? Okay, let's do this. So you can also sort the data, right? You can sort by a condition, or I mean, or by, yeah, somebody. Okay, yeah. So one is position based, one is location based. So I'm trying to think of the right. There's a term. Just give me a moment. Let me see. So okay, with iLock, right? With iLock, you can. It's based on the position of the number, but with lock, you can use the columns, right? For instance, okay, let me do this. df. Yes. So with iLock, basically, you don't need to. You don't know the column names, right? It's just by the the numbers basically. So let's say do this, comma, let's see, so with this, I don't need to enter any string in here. I just need the numbers, and that's what iLoc will do for you. But if I change this to that's to LOC, right? Loc, basically I need to specify the column and everything. For instance, with this, one is position based, one is location based. That's just basically the difference. So with this, I need to specify start, X. This. I think I made a mistake somewhere. Keyword start. Let's see. I made a mistake somewhere. So just reverse. Yeah, that's this. So just a moment, let me look through what is shown here, I think. Okay, yeah, square brackets. Okay, sorry. There you go. So you have to specify the, what is this? You have this. Also the capital letters. That works. Yes, specify that. For the loc, you use the, I mean, you have to specify the string, right? String, the column names with in quotes. That way you can access it basically. But for the other one, you just use the numbers to do that. So it's something I'm trying to look for. That's it. Let me check. Yes, so okay. Yeah, so I think that's that. Let me see. So we can sort the data. So we can sort the data by either by any of the columns, basically. Yeah. So if we have, for instance, this, so we can decide to sort this data. For instance, since we have miles as the only columns with numerals, right, with numbers, we can decide to sort the data by these numbers. So the way to do that is, let's do this sorted. So you call that's the data frame dot sort underscore values by equal to, so I want to sort by miles. Yeah, I think keyword is ascending. So ascending is equals to true. Okay. So what we want to do is, with this data, I want to sort this data by miles, right? So what we've done, okay, well, what we've done here is we're going to be sorting by miles here. It says that in ascending order, right, from the smallest to the largest, and we'll bring that to sorted. So if you run this sorted, if you type this, see, if you look at this, right, this is random. The numbers here are random, basically. I want to sort from the smallest, that's from the smallest mile to the largest one. So if you look at this, from this smallest one to, if you scroll, if you keep your eye on the miles column, you see that it keeps increasing from 1 up to very end. So that's what we've just done. We've sorted by doing that. So this command is, this is it, the data frame. The command to do that is sort underscore values, sort by miles, then ascending. That's ascending equals to true, that's from the smallest to the largest. We change ascending equals to false, right? That's to do that in descending order. So if you do this and run this again, so it's done that. If you can remember, this is the largest mile, right? Then if we look down through this, it sorts all the way to 0.5. So that's how to sort the data by a specific column, basically. You can also sort with two columns, right? So how that works is, let's scroll down. Let's say double sort dot sort underscore sorting by miles. Yeah, okay, now let's start this first. Repository list. Let's see, true, false. Okay. It's easier to explain it when I've run the code. So we can also sort by with two columns, right? So if we look at so what we've done here is this. This is the data. We sort by start, that's the start column and the mouse column. Now we've passed two arguments into this, right? We have the true and the false. So what this does is this, it's in ascending order, the starts, it arranges the start values and then compares it by the mouse with false. Okay, let me explain that here. So if you look at this the start location is given as this, right? Agnew, right? Then if you look at this, the miles, it starts from the highest number of miles to the lowest. So from 4.3 down to 4.24 Agnew. Since this start then moves to the next alphabet, because this start is moving alphabetical order, but it's increasing as we move from A to Z. So A like that. So if you notice, this column is increasing. Then for the number of miles, for every particular location, the number of miles will decrease. Okay, this one has just one. If you look at for Apex again, you see for that's all of A, then the miles decreases. So you can sort by two different conditions. For a particular location, you sort by decreasing miles or increasing miles. You can change this the way you want, and that should work as well too. I think we're almost done for today. So, okay, then, I mean, there are tons of things you can do. One thing you can also do is adding a new column, right? Let's assume you want to add a new column to your data. How do we do that? So, let's use NumPy for this. This df access that. So go. Let's use my mouse. Start. Trip. Short trip. I think they should work. Let's see. Okay, so what I've just done is I've added a new column to the data. If you look through, so if you look through the data, we already, I mean, it ends with purpose as the last column, right? The purpose, but here you see, you can see miles, what's called category here. So probably, I think next week I'll explain how to use, how to use NumPy library. But what I've just done is this. I named, this is the data itself. I added a category, added another column to it, but with square brackets and the name. I chose this name, it's up to you to choose the name you want. np dot where, I don't want to confuse you, but I'll probably explain how to use this later. But with this command, what I just did is for every mile so I access the mile columns, right? Any mile, recorded mile that is greater than 5, it's a long trip. Otherwise, it's a short. Otherwise, it should be a short. A short trip should be recorded. So if you check this, look at 5.1 greater than 5, the long trip. See 5, okay, or equal to anything less than that, short trip. For 63.7 long trip, like that. So that's basically what I've done with this command. For now, I can't really explain much about this so that I don't confuse you, right? But this just shows how you can, if you need to make any column in addition, you can just simply, what you need to do is here you input the name you want, the condition, you can say, or if is equal to a certain value, do that. Then if it's this, you call it this or that. Next week, I'll explain more on how to use NumPy and where, so I'll explain how that works, basically. There are many ways you can also add data to it. It's not limited to using NumPy or this. So you can also decide to, if you want to populate data with, let's say you want to add a year. This data was recorded in I think 2016. Let's see, numpy.array. So I just added another column to this, right? By simply saying for every row, just put the last column of 2016. There's another way you can probably make it variable for every row, but that's a bit complex. I don't know of any simpler way to do that. So, but if you look at the data, we have an extra column here, right? Now, if you notice one thing, the original data has not been changed. Nothing happens to that. We only have an instance of it which we are using, which we are working with here. So we can decide to save to CSV file for our own use as well. So let's see how that is done. Save to CSV file. Then let's see, you give it the name you want. Let's call this new analysis .csv. So what I'm trying to do is I've made changes. So the original data has not been changed, right? But I want to copy what I've read, all this analysis I've done or anything I've done here. There are many more things you can do. During the week, I'll probably write that out on me. You can fill blank spaces, you can do competitions. I'll write that out in the notebook and send that. But for this one, I just want to save, you see, I've added 2 columns to this. I want to save all of this to CSV file. What I need to do is do that, then run this. So if I check, what is that? So if I check my working directory, this is the file already, new analysis is there. If I open that, you should see two new columns. So if you look at this clearly, you can see miles, that's, yeah, additional columns are here, right? But you still have the order. This is the original data as the working trajectory, still, I mean, the working directory is still there. So that's how you can save data to a new CSV file. You can, there are many other things you can do basically, but I hope this kind of helps you get understanding of what can be done basically. During the week, I think, yeah, I'll probably think of some other things that can be done, and I'll write that in the, I'll type that out in the notebook, so it should be easy for you to run and do whatever you need to do. So if you have any questions, you can ask. Are there any questions? I mean, time is fast spent. I probably wanted to show how to use a for loop, but I probably will do that maybe some other time. Okay, I'm seeing some of this direct message. Let me see. Okay, I'll reply the direct message direct. I mean, I'll reply that in private. Okay. Yeah, so let me see. Okay. Sure, no worries. Yeah. I mean, I wanted to talk about for loops, while loop, and all that, but time is fast spent. I'll probably send a notebook about that and make it explanatory. Then probably there are questions you can ask next week about it. Yes, it's possible to change the name of the column, right? It's possible. Let me, yeah, it is. Let me see. It's possible. How do I do that? I mean, so also sometimes if you can't remember, I mean, you can't obviously remember all the commands and everything, right? But okay, let's do it this way. Change column name pandas, right? That's how it works. Let's see. I mean, you see different suggestions, but see, Stack Overflow is always the correct one. I mean, you tend to see. So yeah, so from just looking at this, I can see the command, right? I mean, sometimes you're not sure of something. Even I don't remember every, of course I can, there's no way I'm never going to remember everything. So just copy, I mean, what you just do is you probably copy this, maybe the old one, then you replace it with the new one, and this should work. Let's try it though. Let me see. I'm trying to copy this first. Okay, anyways, I'm seeing the command. I think it's rename, right? It's on there. Just this one. Yeah, this one. So So let's say we have a variable start. Start this. Okay, semicolon, then touch. Let's see. I think that's what was done. Yeah, so that's it basically. I mean, I just Googled that right away. So they have done rename. This is the old one. I mean, the old column, the new one. I renamed that. So I think there are a couple of things you can always do, right? But at least once you just know how it works, then you know what to look for. I think that's the idea. So df dot press tab. I don't know why mine is not working, but ideally if you press, let's see. Oh. Okay, it's because it's been there. It's not a different stuff here. So that way actually you can rename columns. There are many things you can really do. Yeah, no worries, sure. Okay.